Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Stop Frustrating Your Developers, How to Isolate Developer Risk Without Getting in Their Way, brought to you by Isolate. Before we get started today, I do need to go through some housekeeping items with you. As a reminder, this session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will send you an email with instructions for how to access the webinar on demand, or you can always visit us at devops.com/webinars. It will be there for you as well. You are welcome to submit questions at any time during today's presentation. You can use the Q&A tab to send those in. We will try to get to as many as possible at the end of the presentation. And as another reminder, stick around till the end where we are doing a drawing for 4 $25 Amazon gift cards. So stick around and see if you are a winner. Finally, with that, I am pleased to introduce to you today Tal Zamir. He's the co-founder and CTO of Isolate. At this point, I'm going to put myself on mute and turn my camera off and turn it over to you, Tal. Take it away.
Thanks, Sharon. Thanks, everybody, for joining this webinar. Today, we're going to talk about this trade-off between developer freedom and developer flexibility, productivity, and the other side, which is security in the enterprise and security teams trying to isolate the developer risk. And you probably are familiar in one way or another with this trade-off between the two teams. Before we get started, just a bit of background about myself to give myself credibility as I go through this webinar. So I'm the founder and CTO of Isolate. I spent all of my career, almost all of it, as a developer myself. So I know it firsthand how it is to be a developer in an enterprise, in a startup. And I've been originally starting my career in the Israeli Ministry of Defense, where I've built cyber products, as well as later working for VMware for many years. So I know how it is to build enterprise software and this kind of trade-off that we're going to talk about. The agenda for today would be first to realign us all of the security risks associated with developers, DevOps teams, and talk about a few of the common developer team setups that we see out there in big, small, medium software companies, or just any company that has a group of developers in it. I'm going to discuss how IT and security teams try to handle developers today and come up with the pitfalls and challenges they have, what we hear from our customers and prospects. And finally, I'm going to suggest a few ways to create a win-win situation for developers and security teams. So stay with us. So before we get started, just to give you a few examples of how developers and cybersecurity intersect in the real world. So one famous example that some of you might bumped into is the LinkedIn breach from a few years back, where basically a Russian hacker was able to breach a LinkedIn engineer's home endpoint, his own home PC. He actually looked up that engineer on LinkedIn to find out that he's an interesting person to get to the LinkedIn network through. And once they found his PC, they also found he had a web server listening in on an incoming port on his device. So they found a vulnerability in that web server. They breached the web server. Then they were able to own the engineer's endpoint. And from there, it was easy to get into LinkedIn's network, because by the end of the day, that engineer had a client certificate that allowed him to connect to the VPN and to have access to the LinkedIn network. So the hacker was able to get from the user's endpoint to that certificate, then was able to connect directly to the LinkedIn network. And eventually, he dumped the whole LinkedIn user database, or most of it, exposing user passwords and other details to the world. And that was a big, massive deal for LinkedIn at the time. And it all started with a developer working for LinkedIn and getting breached through the endpoint. So that's one example. A more recent example that all of you surely have heard of is the SolarWinds case, a supply chain attack, where basically hackers were able to get into the SolarWinds network. SolarWinds creates IT monitoring software and other products And basically, once they were inside SolarWinds, and they probably breached SolarWinds through the endpoint, which is most breaches today. And once they were there, they were able to observe how the dev process works. They were actually, we don't know the details, I don't know the details of how they got into which devices they were able to infect, but they were surely on some of the developer devices, seeing how they commit code, how the build system works. And once they observed that, they were able to inject code into the signed product executables that SolarWinds produces, and basically put a backdoor inside the SolarWinds product. And once the SolarWinds product got updated automatically, 18,000 users downloaded compromised versions, including some government organizations and others, a very serious breach. And it all started with a tech company and probably some of the developers in the company, the DevOps teams, and so on. So this is how, in the real world, we see developers and security intersect. But in general, of course, dev and DevOps devices and infecting them and compromising them can lead to all kinds of consequences, including massive data breaches, like the case of LinkedIn, where company data or sensitive customer data is leaked, source code leak, which in some cases is a big deal. Actually, in VMware, where I used to work, there was a major source code leak where the VMware source files for their hypervisor was leaked. And for Microsoft, Windows source code was leaked in the past. There's supply chain attacks where, like in the SolarWinds case, you can get to modify the source code and inject backdoors. There's reputation damages like website defacement, and just the plain old denial of service where you can bring down whole production workloads and even lead to significant business loss, or just in fact the endpoints developers are using to bring them to a stop and lead to minor consequences in that case, but still an unpleasant disturbance. So there are the kinds of examples of security risks that we can all experience as dev or DevOps teams. And as I mentioned before, many of those breaches involve endpoints, because by the end of the day, for the attacker and from the attacker's perspective, getting into the endpoint is usually the easiest path in, because endpoints are operated by humans and we all make mistakes. And endpoints are considered the weakest link in many cases. And another problem with endpoints is that they mix multiple types of activities. There's, on one hand, risky applications, which are internet-facing, like email and web and instant messaging, and many others, to which risky content can arrive and infect the device. And on the same operating system, you also use that device to do enterprise access, to get to enterprise documents, the source code. You can, even if you do it through VPN or through VDI, eventually you get to enterprise resources that are sensitive and you do not really want to mix with the day-to-day applications. But the reality is that on the same operating system, you do multiple types of activities which are completely different security domains and sensitivity levels. And as soon as one of those risky applications gets the attacker in your device, they can get to own the OS and move over to the enterprise resources. And they use techniques like keylogging or credential theft or even screenshots and user impersonation. So they can really ride whatever session you have authenticated with the enterprise to gain access to all of your systems, get the data out, and do damage on production workloads if they want, and so on. They move laterally within the network. They take whatever documents you might have stored locally, your credentials, your cookies, your access tokens. And of course, beyond the external attackers, there's also the insider threat, where basically an employee can go and do harm deliberately or by mistake on his device if he has access both to the wild internet and to enterprise assets and have full control of his device. And they can lead to those breaches as well. So that's kind of background on the developer and DevOps team risks. And now switching over, let's talk about how typically developers work in an enterprise environment. Some of the top setups we see out there. So the first kind of dev setup or persona for developers is what I call here the frustrated corporate developer. Basically, think about a developer in a small, medium, big enterprise, usually in the bigger enterprises, where the endpoint is typically could be a Windows or Mac machine, which is in the Windows case typically heavily locked down to whatever extent is possible for those developers. And this could include security controls like blocking access to uncategorized or risky websites, a very popular restriction that many enterprises use. They can limit the types of apps you can run on your device with app whitelisting. They can limit what browser extensions you can install with enterprise managed browser extensions. They can limit user permissions so you don't have full admin rights, but rather only able to access certain things. And they might put a local firewall product on your device that prevents running local servers, listening on incoming ports, and so on. They might block USB devices that you need to plug into your device for doing your work or for personal reasons to prevent data leakage. And in many cases, they install EPP and EDR products, endpoint protection platforms or endpoint detection and response that practically scan every file you access on your device. If you're building some software, there's going to be a lot of files you're going to access during the build process, and this slows down the experience for the developer and the build time. They might be fully auditing your actions on the device for fear of insider threats and data leakage again, and put multiple authentication factors that you need to go through. And especially now during COVID and when people are working remotely, they might have always on VPN. So when you're connected to your home network, your laptop cannot just be freely connected to your home network, and you are forced to use a VPN at all times, preventing you from accessing, your local resources and not being under the control of the enterprise network security. So that's a set of examples of lockdown and restrictions enterprises put on the frustrated corporate developer. There's also another type of restriction that sometimes you get, which is basically when you need to do something which is considered privileged or extra sensitive. You might have a separate device, privileged access workstation in some cases, which is used just for accessing something which is privileged, sensitive. In some cases, it's an actual second physical laptop. In other cases, it's a jump box or a jump host you go to do those sensitive actions. And this is for bigger companies. One famous example of that in action is Microsoft, which practically hands out privileged access workstations, physical laptops, to thousands of their developers. Whenever they need to access the Azure infrastructure, they're actually doing it from a separate physical device. And this is definitely further frustrating their developers because they need to have two separate devices wherever they go in case they need to do something privileged. So that's persona number one, the frustrated corporate developer. A second one, which is kind of the opposite, is what I call the unleashed developer. This is a lightly managed endpoint where the developer has some security controls on it, but basically can do more or less everything on the device. They have full web access, they can install any app, they can run any code they'd like, install browser extensions, have some local admin rights, run local servers, connect peripherals, the reverse of what we've seen before. And from that same device, which is loosely managed, they have access to source code and production servers. They might need to do a second level of authentication, but by the end of the day, they do get access from that same fully open or mostly open device to the sensitive assets, including using that device at home. In cases where they put some kind of controls on those unleashed developers, it's very minimal. It could be some endpoint protection solution or EDR solution, maybe a VPN client that you need to connect, and maybe in the worst cases, a mobile device management solution, something like Intune that takes over some parts of the laptop for visibility and for configuration of the laptop to enforce passwords or encryption of the device, but a very minimal level of enforcement. So that's kind of the second unleashed developer persona. A third is what I call the remote developer. This is typically for contractors, outsourced development groups, and so on, consultants. And there, the way it works is that the developer doesn't really use their own device to do the corporate development, but rather uses a remote desktop sitting on virtual desktop infrastructure, VDI, or desktop as a service, DaaS solution, where they have a lockdown Windows desktop, typically they use to do the development on. And locally, they use for anything else, for their personal needs or for the third-party access. And that their own physical laptop is not managed at all, while all of the development is done remotely on a remote desktop. This, of course, leads to frustrations on the network connectivity side of things, where if you're on a bad connection or a high latency connection, then every click you're going to have is going to take more time. And it's frustrating to work like that as a developer. And also, to really give you a good experience as a developer, the backend infrastructure for those virtual desktops in the cloud or in the data center needs to be a high-end storage, compute infrastructure to give each developer enough resources to have a reasonable experience while they're doing their development on that remote desktop. So typically, users here are less happy with the experience, and the enterprise does get to keep the development close to the data center or their cloud infrastructure. So these are the top three setups I see out there. The first one, lots of frustrations for the developer because of the lockdown, but lots of control for the enterprise. The second one is a lot of freedom for the developer, but a lot of risk for the enterprise team. And the third one is kind of in between, where the developer does have freedom on their own devices, but by the end of the day, they need to work over a remote connection and a so-so experience. And on that remote desktop, they still get some lockdown. So these are kind of the top three cases we see out there. And as you see, as I go through this, it's a lose-lose situation, right? Between security and IT teams on one hand, and developers and DevOps teams on the other. And many of you might be experiencing this lose-lose situation in your day-to-day. Because on the one hand, security and IT wants to minimize risk by restricting what developers can do. That's their job. And they want to minimize the total cost as well as part of this. While developers and DevOps teams want to use any website to do their research and to use the laptop for personal needs. They want to use any modern cloud service, any modern application, IDE, any endpoint. And they also expect to have a great local experience everywhere they are, especially today as they work remotely. They expect to be able to be productive everywhere. So that's kind of the way it looks. And it seems that someone has to compromise, right? Either security teams that will need to be doing compromises and do exception handling. So when a developer needs to access Stack Overflow, they will whitelist that website in their web proxy and take the risk. Or when someone needs to use a new tool, a new application, a new package, they might need to explicitly whitelist that application or website or what have you. Especially also during COVID, when people are working remotely, they cannot force users to be always on the VPN, because by the end of the day, when you're working from home and you need to access some cloud application, some conferencing application, you don't want to be forced to tunnel all of your traffic through the corporate network before it goes into the cloud application eventually. So security teams have to allow your laptop to connect simultaneously to the VPN for on-prem applications and to the cloud directly for modern cloud applications and conferencing applications. And that's another risk they take and compromise on. And finally, granting local admin rights is another example. That's something that security teams really don't like doing because of the risk of running any software and disabling all of the security controls, but they end up doing in many cases for many developers. And on the developer side, developers do their own kind of compromises if they're using some virtual desktop in the cloud or in the data center and work over a remote connection, that's definitely a compromise on user experience. If they're using a second endpoint for risky or sensitive access, like the privileged access workstation at Microsoft, that's another compromise they make. If they're forced to always be on a VPN connection, that would use their bandwidth and again degrade their experience, that's another compromise. And if someone is asking them to enroll their endpoint in some Intune, MDM, as they call it, system for managing their endpoints, or someone asks them to install an endpoint protection solution that could invade their privacy and look at their file access and so on, that's something that is a compromise as well. So that looks kind of, a lose-lose situation. But organizations still try to solve this and reduce the pain. And I'm just going to go through a few examples of how organizations try to solve this today. So one type of solution is something called endpoint privilege management, where basically it allows organizations to manage the local admin rights and applications you use on the endpoint and be able to set fine-grained policies around which applications you can access, which rights you get, and to organize a process for requesting those rights and approving those rights. But while it gives you more control and more visibility, it does still force you as an organization to be in this exception handling business. And by the end of the day, you do allow developers to run some apps and get privileges, and you take the risk. So it doesn't really solve the problem for the users or for the security teams. It just improves the way you manage it. It's still a lose-lose, right? With another approach, which is called browser isolation, you might give developers wider access to the web by letting them visit uncategorized websites or risky websites via a remote sandbox browser. So when you try to visit Stack Overflow, as an example, you might gain access to that, but via some kind of remote browser and not a local one to reduce the risk. While it does eliminate a lot of the risk of browsing, it doesn't support any application which is not a browser. So if you want to install something or put another extension or do something which is non-standard, this is not going to be supported, as well as it kind of degrades your experience again because you're working through a remote browser and not a local browser. So you might run into performance challenges or web compatibility challenges as you use such a solution as a developer. There's also the VDI and desktop as a service, remote desktop approach, which provides the developer a remote desktop for development. But again, the experience here could be significantly worse if you're not on a best network connection or if the underlying infrastructure isn't enough to keep those running for everybody at the same time when everybody's working remotely. And as we mentioned before, MDM solution, device management solutions, which enroll third-party devices in a management system to verify compliance, encryption, or do some kind of endpoint security on the device, they suffer from pushback from those third parties and users that don't really like the fact that someone is monitoring their activity on the endpoint, which is theirs in some cases and a third-party organization in some other cases. So this is the main approaches we see out there. There's also an approach of trying to put some kind of local virtual machine on the developer's device, for example, with VMware Workstation or Hyper-V, and letting developers access higher or a lower security zone on their devices locally in a separate VM. So you have one operating system, which is, let's say, your corporate environment, while another operating system in a VM is a risky environment, an unlocked environment where you can do more as a developer. The idea is, of course, to get to this win-win with security and developers, because developers get their full freedom in the open zone and a lot of flexibility, while the organization gets security and hardening on the corporate zone. So this is a nice concept that can get everybody to a win-win, but there's a few challenges with traditional local VM solutions, like VMware Workstations and others. First, there's a challenge with user experience. So if you think about it, putting a VM on your device, a virtual machine for some other persona or other security zone, can still confuse many users. And if you don't have a lot of discipline, you will get confused very quickly. Where should you run each application or each website you're trying to visit? It's not easy to know, and you might do actions in the wrong environment, and then there's no point to the separation. Second, you might, the organization or you, if you have admin rights, you can incorrectly configure the virtual machine in terms of network settings or clipboard settings or what have you. And by doing so, again, miss the point and not get the security benefits you expect. And also, traditional local VMs have a lot of overhead in terms of performance and other aspects that will not make it very practical for developers to use them. A second type of challenges with local VMs traditionally is that they don't really provide a lot of enterprise security controls for the security teams. So you cannot really have a management console where you configure the hardening of the virtual machine, what network access the virtual machine has, what kind of clipboard controls you have over those VMs, and fine-grained controls per direction and so on. You don't have built-in auditing or anti-tampering features with traditional VMs. And there's also lacking central manageability and ease of manageability for VMs. Because if you want to go and deploy VMs for each and every developer in your organization, someone will have to build an OS image and keep it up to date and deploy 30 gigabytes of a Windows image to each and every developer, buy a license for a separate Windows OS or whatever you per user, make users download those images, and you need to configure some kind of way to push policy updates or image updates to those VMs, which is challenging. So these kind of the main challenges with traditional local VMs. So while the idea is great, there's missing pieces in it. And of course, this is where Isolate fits in. Basically, Isolate is a product meant to provide this kind of seamless split of your endpoint between two different security zones, allowing users to be both productive and secure at the same time, while filling the gaps of user experience and performance and manageability and security. So for example, you might have two zones. One is a risky zone for risky applications or full web access, while the other one is a sensitive lockdown zone for sensitive apps and so on. And we give the enterprise the full controls to create those VMs in a very easy way, a very lightweight way without all of those downsides. I want to just spell it out for you in terms of what are the use cases for our technology at Isolate. So the first one is what we call a playground for corporate developers. So if you think about that frustrated developer, which has a lockdown endpoint with lots of security controls, with Isolate, suddenly that developer within 2 minutes can get a playground environment or a sandbox environment on his device where he can practically do anything without almost any restrictions. So here you can think about anyone who's suffering from those lockdowns can suddenly get free access to online content that he needs for getting his work done, be it training videos or guides or blog posts or Stack Overflow, again, as an example, or trying out new applications, new tools without waiting for IT to approve each and every application and tool, just using them in the sandboxed playground environment. You can run software that requires admin rights. You can even use your endpoint for personal usage as well without compromising the security of your organization. So that's a classic use case for the Isolate technology. I want to show you a quick demo of how it looks like in action, just to get a feel for it. So I'm going to show this on my own laptop. This is a corporate laptop with lots of lockdown. I don't have admin rights to install software. I don't have full access to the web, and so on. And I do want to get Isolate up and running and use it for my free access to the web, for installing apps and so on. So the way it works is that my administrator can provision Isolate for me automatically and install Isolate for the developers in the organization. It takes literally 2 minutes with a lightweight installer. And once this is done, I actually have a second zone on my machine. I'm going to flip into my zone with keystrokes. And you can see how I'm flipping between the blue world, which is my corporate environment, and this purple world, which is my Isolate sandbox environment. In this case, the playground environment. So switching is like switching between two these different spaces on your Windows machine or on your Mac, where you just switch to another desktop, and it looks like just another desktop. I don't need to really understand that it's a virtual machine. It looks just like the time is synced, the languages are there, so it's all the same, other than that colored distinction. But if you look under the hood, you'll see that while my host OS is full of applications, as you would expect from a corporate environment, my virtual machine was spun up instantly from a clean Windows binaries that I have on my host, and basically doesn't have anything other than a few apps that my organization wanted me to have in the VM. In this case, Chrome and Edge and Notepad++ and 7-zip. But under the hood, it's not a full-blown OS image, which takes 30 gigabytes of disk space. It's a very lightweight image with a few gigabytes for spinning it up. And it's very lightweight, doesn't contain almost anything initially. Now, when I'm gonna have this, after I have this, I can use it for all kinds of purposes. For example, I'm gonna show you, after I booted the environment and have it installed, if I'm trying to visit a website that was originally blocked by my organization, in this case, Metasploit, for example, I'm going to be blocked on the corporate side, but without touching any keystroke, it automatically gets launched in my virtual machine, and I can access this website to try all kinds of things. And this can, of course, be fully configurable by the administrator of Isolate to decide which website categories go into Isolate and which stay on the host. So you have full flexibility. We actually give in some free version of the product the user the ability to decide which categories of websites get automatically redirected to the other side. In this case, it's hacking and cracking, but you can customize it to redirect to the sandbox environment any category you'd like out of a list of categories. And then it will be automatically redirected. But beyond that, any other thing you want to do safely or need to do safely can be automatically redirected. For example, I don't have admin rights to run this VLC installer that I have here. But if I'm going to right-click it and ask it to open in Workspace, then basically it automatically transfers this file over to the VM and launches the installer for me in that virtualized sandbox environment. So I can here have admin rights and just install it as I would normally install any application without any limitation that I would have on my corporate environment. Of course, I can also open admin command prompt on this device if I need to, because here I have full admin rights and I can play around and do whatever I want in this safe zone. Also, in the web browser, I can also right-click any suspicious link if I want to explicitly open links in Isolate. So in this case, I got some suspicious email with a CV that I'm not sure is right, and I can just open in Workspace, and again, Isolate will automatically redirect it to my sandbox environment. And this is, of course, all configurable centrally by the administrator as well. Other than that, copy and pasting is something you can also fully control as a security team and decide that certain types of content is pastable into the other side, given certain restrictions or your desired policy with fine-grained controls over what is allowed to be transferred in each direction and so on. And of course, if that virtual machine does get compromised eventually with malware, let's assume I was able to infect my VM with a very visible keylogger, as you can see here. Now, whenever I'm going to type something on the VM, like this is my virtual machine, you can see that the keylogger just captured that. But when I'm going to switch over to my corporate environment and type something which is sensitive, like this is my password, corporate secrets, This is not going to be recorded by the keylogger, although it fully controls my guest operating system that is within the VM. And this is, of course, by design because it's a virtual machine, so everything in it is just trapped, including screenshots and keylogging and networking access and disk encryption that we put in place, and copy and paste and printers, and you name it, everything is trapped within that VM. So that's kind of to give you a look on the isolation in action. Of course, just to give you a glimpse into the manageability of it all, it's all centrally controlled by a isolated administrator that has full visibility into the virtual machines that are deployed in the user's devices and control over the policies that are set for those VMs. So here I can look at, for example, the copy and paste policy between the VM and the host, and basically control what kind of content is allowed in each direction. Do I ask the user for approval? Do I limit the size of the transfer? And in each direction, so from the VM to the host or vice versa, I have full control. Same goes for external devices, the peripherals that you might want to put into the VM. You have control over those USB devices and printers, and you name it, what is allowed within the VM and what not. You can also limit the network access of the VM to ask the VM to only have access to, let's say, a VPN gateway or to a set of domains that you want to allow the VM to access. There's also the applications you can push into the VM, as we just presented. So you can upload applications that you'd like to have automatically pushed into the VM, and they will get installed automatically. The magic also is that you don't, as an administrator, ever need to create a VM image, to update a VM image, to deploy a whole VM image. It just gets forked from the underlying host binaries, the Windows clean, trusted binaries, and this is automatically being provisioned like magic into your device without the bloat of full VM. We also, of course, put in place lots of performance optimizations so that it doesn't feel like a VM, and it's actually automatically being paused when it's not in use. So basically, you as a user, but also automatically can configure the VM to automatically pause after a selected time period, and the VM will not consume any resources of your device while it's not being used. So only while you actually need the power of that second sandbox environment that you'll get, you actually get any kind of extra resources for the VM. That's just to give you a glimpse into Isolate and what we do under the hood. And I want to continue here to describe additional use cases, because we talked about the first one, which is a playground for corporate developers, but there's also other very useful use cases. For example, for DevOps teams especially, there's a way to get a convenient and secure privileged access zone on your device. So think about this poor corporate developer that needs to access simultaneously his corporate email and a privileged environment on a second device or a jump box. With Isolate, you can set up this privileged environment that spins up instantly on your device and lets you access, let's say, Azure infrastructure, AWS, vault of secrets or documents or what have you, or your build process, build servers, and without risking your environment, be it from external threats or from insiders. Basically, that VM will be completely isolated and nothing will go through except for maybe text that you can copy or whatever you decide as an administrator of Isolate. And by having this second privilege environment, you can suddenly relax some of the security restrictions you put on the main development environment, because they're no longer needed, because you have the more sensitive stuff in the privileged environment. And this is where you actually harden to the extreme, while the development environment can be a bit more loose. This eliminates the need for a secondary endpoint or a jump box, and lets you work safely and knowing that your privileged access is secure. So that's a second use case for Isolate. And the third one is for those remote developers that used to work on a VDI and DAS, remote desktop of some sort from an unmanaged device. With Isolate, we can give those developers a local, isolated corporate VM, which is used for development, without touching anything on their unmanaged OS and on their personal third-party environment, without needing to invade their privacy or enroll their original OS in some Intune, MDM solution, and so on. You get the VM to be where you do your access to the corporate network and to the development environment of your client or what have you. And then, if your own personal laptop is infected, it will not be able to reach out to the corporate network or to leak data out and so on. You as a developer get a much better experience because it's all running locally and you don't need to suffer the lag and the bad experience that you sometimes have over VDI and DAS. And you have your own dedicated hardware that you already own, so you can use that for running heavier workloads. If you have external development teams or outsourced teams, you can onboard them and use their help without a lot of effort and instantly spin up this VM for their access. So these are like the top 3 use cases we see out there for developers and DevOps teams with Isolate. And the nice thing about it is that it finally gives you kind of a win-win between security teams and developer DevOps teams. And with that, I want to leave you with just a few notes. First, I'm sure you're all aware, but today more than ever, developers and DevOps teams are really high-end targets for the bad guys. The threats are very real. We see them on the news every week. And it is possible to get to a better situation where less compromises need to be made. And security teams can get to sleep well at night while developers can get their freedom without compromising on a lousy experience and without compromising on lousy or more exposed security posture. So with that, I want to hand it over back to Sharon for Q&A. Thank you.
Oh, sure. Thank you. That was awesome. All right. Well, we did have some awesome questions come in too, so let's jump right into it. Here's a good one. When you were demoing, this question came in and asked, how can developers move things between the 2 environments there?
Thanks. Good question. So basically, with Isolate, you can have full control over what you allow the developer to move between the environments. For example, you can set up a policy where you can copy and paste any text you like just from this direction to the other, or vice versa. Or you can say, I allow text and images or files, as well as control the size limit of what is allowed to be transferred. So we have the controls available, but of course, the organization needs to decide what they allow and what they prevent developers from doing. But if you think about it in the use cases we presented, for example, in the DevOps case where you want to access a privileged environment, you might don't want to allow files to be transferred in each direction. You might want to only allow text to be moved from one side to the other to prevent threats from crossing over to the privileged zone. But you have the controls, and it's up for the organization to decide.
Okay. Yeah, that makes sense.
Thanks.
Yeah. Let's see. So here is another great one. I hope I'm going to kind of paraphrase this correctly. Would providing developers with an isolated environment like Citrix VDI or Subnet that's completely different from the production environment be beneficial? Basically, it would be like an isolated zone for their test and dev requirements.
Got it. So if I understand the question correctly, definitely if you provide a separate Citrix VDI environment, that could be giving you the security benefits of OS isolation, where you would have a separate OS just for a certain security domain, security zone, with certain security restrictions. The challenges we see out there with our customers and prospects when they try to adopt VDI or DAS is that they get a mediocre experience for their developers or DevOps teams, where every click and every keystroke takes a second to pass through, and this is driving the developers crazy in many cases. To add on top of that, it's it's not under the organization's control, right? Even if the organization invested millions of dollars in the underlying infrastructure to be able to run thousands of virtual desktops for the developers, and it's really is this order of magnitude total cost of ownership for VDI or DAS. By the end of the day, if you're at home during COVID and you need to do your work, but your kid is doing a Zoom session in one room and another one is doing Netflix on another, your bandwidth will be limited, your ISP might be hogged and go down, and then your experience will be even lousier. And that's not depending on any investment the organization does. So there's a big user experience challenge related to VDI or DAS, things like Citrix or VMware, Horizon, and so on. But it is a viable option if you have the dollars to spend on the underlying infrastructure to set up multiple zones on top of VDI or Citrix. But the user experience will be so-so, and the cost will be astronomical.
Yeah. And I have been there, and that is super frustrating. Okay. So let's see. Well, I'm going to jump to this one since we were just talking about performance improvements. What performance improvements make Isolate perform better compared with traditional VMs?
Great question. So definitely, we've all been using, if you're a developer, you've been using a virtual machine in the past. And, just having a full VM that runs a completely separate OS with a full copy of everything the OS needs in terms of disk space and memory and so on, you'll hit performance issues. Some of the performance improvements we've made under the hood, and a lot of it is standing on the shoulders of giants with the latest advancements in virtualization by Microsoft. We're actually putting in place optimizations over every aspect of the virtual machine that you can think of. For example, because the VM is spun out of the original operating system you had on your device, you don't need to have 30 extra gigabytes of disk space just for the VM, because the guest operating system points at the clean OS binaries that are already there on your device. So it typically only takes 1, 2, 3, 5 gigabytes, depending on how many applications you want to install in the VM and so on. And also in terms of performance, like scheduling of the virtual machine and video optimizations and audio optimizations and power saving, we made the VM more intelligent, and the OS is aware of that virtual machine and can better schedule it and better allow it to do all of those things without consuming a lot of resources. There's also dynamic memory in place and other GPU acceleration and other optimizations that make it feel like a native OS. It's still a virtual machine, but together with all of these optimizations in place, it's negligible, the total impact of that virtual machine.
Okay. All right. I think we've got time for one more here. This one goes back to the beginning, kind of where we started here with this presentation. Isn't strong user and device authentication enough to reduce developer risk? Why do we need to go further than that?
Great question again. Thank you. So basically, if you think about it, there's also the example I just gave at the beginning of the deck, where basically on the LinkedIn breach, they did have strong authentication, right? They had a client certificate, which is not common, and of course there was username and password, and all of those things, multiple factors of authentication that you probably are all using today. But still, once you're inside the device, inside the endpoint, you own the endpoint of that engineer, you have full control. You wait for the session to be authenticated, and you can just ride that session and do whatever harm you'd like once you're inside the network. You don't necessarily need to get the credentials or the second factor. You just need to sit on the endpoint and wait for the authentication to happen and ride the session. And in many cases, like in the LinkedIn case, you can actually grab the credentials, grab the certificate once you're inside that device, take it to another device in Russia in that case, and connect directly from your hacker device into the LinkedIn network. But both options are possible, and there's kind of a false misconception where if I have good enough authentication, if I have a second factor, if I'm doing some basic host health checks for my device, it's good enough. It's not, and the reality shows us over and over that Once the attacker is determined, they'll get to the device, they'll write the session, or they wait for the authentication to happen, and then grab the credentials, grab the database, do whatever they need to do.
Yeah, the patience is the key, and they've got that in spades, unfortunately.
Yep.
All right. Folks, I think that's probably about all we've got time for today. But if you did have a question you haven't sent in yet, please go ahead, send that to us. We'll get those all over to Tal, and he can follow up with you afterwards. Cool. Just a reminder to the audience, the session has been recorded, so if you missed any or all of it, you'll be able to go back and watch it again. We will send an email with instructions for accessing this presentation on demand, or you can always visit us at devops.com/webinars. It will be there for you as well. And now I think it is time for us to draw our Amazon gift card winners here. So let's get right into that. All right, our first winner for today is Jack K. Congratulations to Jack. Our next winner is Paul P. Congratulations, Paul. Bianca P. Congratulations, Bianca. And finally, Mark W. Congratulations, Mark. And congratulations to all our Amazon gift card winners. We will be sending you an email with instructions for claiming your gift card, so make sure and keep an eye on your inbox. If you don't see it show up there, please check your spam folders. All right, and with that, that does it for me. Tal, thank you so much for your awesome presentation, for joining us today. And to the audience, thank you for spending your time with us here. We hope to see you again soon. I am Sharon Florentine, signing off.
Thank you, everybody.